I'm Jared Harrington, and today I will be discussing Lab 1 charged tapes. So, to begin, the objective of this lab was to prepare a piece of clear tape and observe the interactions, then determine approximately how much excess charge is on one piece of charged tape. From there, you will create a computational model to calculate the charge of one piece of tape and then compare your results from the computational model to the experimental model. So overall, the results of this lab were both U-tapes repelled one another, and the U-tape was positively charged. The charge of each U-tape was determined to be this value, and the amount of excess electrons on one piece of charged tape was determined to be this amount. So some relevant physics principles were Coulomb's law, Newton's second law, and gravitational force. These combined will allow us to determine the amount of excess electrons on one piece of tape and also the charge of one piece of the U-tape. So to compare the observations to the actual reality of the experiment, we were asked some questions, and for the first question, it says, what will be the interaction between the U-tape and my hand? I guess that the tape will be attracted to my hand, and this was correct. What will be the interaction between the two U-tapes? The two tapes will repel against each other was my hypothesis, and that was correct. And finally, what will be the interaction between a negatively charged pin and the U-tape? The tape will be attracted to the pin, and this was determined to be correct. So why is all of this important? Using these interactions and observations, we can determine that the U-tape is positively charged in this case. So for the second half of the experiment, we were tasked to tape two or to set up two pieces of tape to a book and have and hold another piece of tape to determine whether or not the held tape would float. So the system in this case was the suspended tape and the surroundings was the held tape. And then here are some values I got in this experiment. So for some calculations, I found the gravitational force, and then you set the gravitational force equal to the electric force, and you do this using the net force and setting that equal to 0. And then I found the electric force, and then using the electric force equation, you can solve for Q, and you get this value. And then from here, to find the amount of excess electrons, you find the surface area of the tape, and then you find the area of one atom and divide both of these. And then from there, you can find the amount of excess electrons, which was this value. And then here is my computational code. From here, you can see the charge that was calculated and the amount of excess electrons on a piece of tape. And then for the discussion, the two models were or shared similar results. However, there were discrepancies. With the computational model, it assumes that the environment of the charged tapes was a perfect one, and this is not the case. And also in the experiment, it assumes that each tape has equal charges, and that is not correct. So some sources of error would be inaccuracies with the calculations, such as rounding too early, and measuring not exactly to the nearest degree. Mishandling the tape could be an error, and also inconsistencies with the tape, such as its length and its mass. So for the what if question, if electrons had positive charges and protons had negative charges, what would change the observations? There would be no change because the same physics principles apply. Opposites attract. And then for our why question, why is it important to handle the charged tapes as little as possible? This is because mishandling the tape could lead to losses or gains in the electrons, which would alter the charge of the tape.